Today, we are talking about Amazon SQS, which stands for Simple Queue Service. Now, I want you to think of it as a super reliable middleman, right? It's this crucial piece of the puzzle that lets different parts of your application talk to each other without having to be directly connected, which, as we'll see, can be a really fragile setup. So let's dive in and see how this thing actually works.
Okay, so imagine this. You've built an incredible application. It goes viral overnight, everybody's using it. I mean, that's the dream, right? But that dream can turn into a total nightmare really fast if your system just can't keep up with the demand. So what happens when that wave of success is so big it threatens to wipe you out?
Well, in a lot of basic systems, all the different parts are what we call tightly coupled. They're directly linked. So think about a food ordering app. The part you use to place an order sends instructions straight to the kitchen system. But what if the kitchen gets totally slammed with orders? Its system slows down, maybe it even crashes. Well, because of that direct link, the order app crashes too. That fragile connection becomes a single massive point of failure.
And this is exactly where our reliable middleman can totally save the day. By sticking a queue right in between our services, we can break that fragile link. Let's take a look at how Amazon SQS solves this exact problem.
With SQS, the whole architecture changes. I mean, look at this. Instead of that direct connection, the order app and the kitchen now talk through an SQS queue. The app just drops the order as a message into the queue, and the kitchen system, it just pulls that message out whenever it's ready for the next one. This is called decoupling. They can now operate completely independently. They don't need to be online and available at the exact same millisecond anymore.
So what is this queue really? Honestly, the best way to think about it is as a digital waiting room. It's just a temporary, super safe holding area where messages, customer orders, data transfers, whatever, can just line up patiently until the next part of the system is actually ready to deal with them.
And the journey for a single message? It's beautifully simple. First, a component, we call it a producer, like our order app, sends a message. Second, that message just sits there, safe and sound in the SQS queue. And finally, a consumer component, like our kitchen system, pulls that message from the queue whenever it has the capacity to process it. It's simple, it's effective, and it is incredibly robust.
Okay, so that's the theory. It sounds great on a whiteboard, but how does this actually perform in the real world when things get intense? Let's throw a really high-pressure scenario at it.
All right, let's imagine a money transfer app. It's payday. Literally everyone is trying to send money to their friends and family, and they're all doing it at the exact same time. The system is about to get hit with the sudden, absolutely massive spike in traffic.
And, we're not just talking about a few extra users here. We're talking about potentially millions of people all trying to make transfers at the same time. Without the right architecture, this is just a recipe for a complete and total system meltdown.
But with SQS in the middle, the system doesn't even break a sweat. The queue acts like a giant shock absorber. All those millions of requests, they're just safely stored as messages in the queue, forming this nice, orderly line. The back-end processing system is completely shielded from that flood, and it can just work through the messages one by one at a calm, manageable pace.
So let's just put it side by side, because this really shows the core difference. A tightly coupled system is fragile. It's like a house of cards. One little bump, and the whole thing can come tumbling down. But a system that's decoupled with SQS, it's resilient. It's like a trampoline. It just absorbs the shock of a traffic spike because that queue buffers everything, protecting all the important components.
So, we know this is a huge benefit for the system itself, keeping it stable. But what about the person who's actually using the app? Let's look at how this asynchronous design actually creates a way better experience for the user.
I mean, think about it from your perspective as the user. You click Send Money. The last thing you want to do is stare at a spinning loading icon for like 5 minutes while all the security checks and bank transfers happen. With SQS, you get an immediate confirmation, request submitted. All that heavy lifting is happening asynchronously in the background. You get a snappy, responsive app, and a few minutes later, your friend gets the money. It just feels fast.
And that right there is the crucial point. The real benefit of using a queue is that the user doesn't have to wait. By processing these tasks in the background, you free the user from waiting. Their initial interaction is instant, and the application feels fast, even if the whole process behind the curtain actually takes a little bit of time.
All right, let's bring this all home. We're going to distill this down into the absolute key takeaways. Think of this as your exam cheat sheet.
This is the single most important concept. If you walk away remembering only one thing, make it this.
If anyone ever asks you, hey, what is SQS for? The answer is decoupling. It lets different parts of a system work independently, which is what makes the whole application more scalable and way more resilient.
Okay, let's quickly run through the other core facts you need to know. First, SQS is a distributed system. That means it's highly available, it's reliable, it runs across a ton of servers, so there's no single point of failure. Second, as we've hammered home, its main job is to decouple your components. Third, and this is important, it uses a pull-based model, not push-based. This gives the consumer, the one doing the work, full control. And finally, a standard SQS queue guarantees at least once delivery, so you can be sure your critical messages are not just going to get lost.
Now, that pull-based model is a really key distinction. SQS doesn't actively push messages out to its consumers. Instead, the consumers are the ones in charge. They actively reach out and pull messages from the queue, but only when they have the capacity to process them. This is amazing because it prevents your workers from ever getting overwhelmed. They get to set their own pace.
So we've seen how SQS acts as this amazing middleman, creating stability and a much better user experience, all through the power of decoupling. So the real question now is, with this powerful concept in your toolkit, what fragile connections in your own projects can you make a whole lot more resilient? Thanks for tuning in.